let's differential equations. So we'll start with linear.
Yeah, linear differential equations.
And then also on linear, it's first order as well as it's separable. The first tutorial we did, it was about separable. So the first question is this dy dx, or we can just put 2y here, is equal to x plus 1, like this. So this is supposed to be how the question will look like, right? Yeah. So if it's separable, what it means is you can separate it, like the x is in one side, the y is in one side, right? That means it can be separated. So for example, that means this one, dx is supposed to go to where the other x's are.
So you multiply both sides.
Exactly. So you multiply both sides. So when we write solution, so we'll take it like you said. So it will be 2y right, as a first step.
Yeah.
Now, having done that, that means we can now introduce the integration, right?
Integration factor.
No, not factor, but integration to both sides. You can just integrate it to both sides.
Oh, okay. Yeah.
If it's separable like this, then the first step, just separate. The second step, introduce integration both sides.
Okay.
So you introduce the integral here, like this. So the integration of 2y with respect to y is what? Then 2 is constant, and then you add y, here 1. Yeah?
Y squared over 2.
Yeah.
So it's y squared.
Exactly. So over 2, and then the 2 will cancel with this, right?
Yeah.
So it will just be y squared is equal to, and here you inside the bracket is you add 1, it will be x plus 3, x to the 3, right? Divided by 3.
X to
the 3, yeah. So it will be x to the 3 divided by 3.
3.
Plus, so here it's a constant, it's 1, so it will be x. It will be x, right?
Yeah.
And then plus C1. You can just put C1 as a constant because we haven't finished yet. So they say you don't have to put the big C. Right?
All right.
It's like we haven't found the solution. So in some let's say in some questions like this, you have different constants like K, C1, C2 in some books. So in the end, that's when you put the big C. So that, because if you put it here in some questions, you can get the wrong C. Let's say it's initial conditions, the one that you substitute to get the C first. Right?
Yeah, it's clear.
So that's why you have to put, you don't have to rush to put the big C. So now you can you can leave the answer like this, but to put it in an equation form, because you have just to make y to have y is equal to something, mostly like an explicit form. So with that, then you can introduce the square root to this, to remove this, right?
Yes.
So it will be y then it will be the square root of this business. Yeah, of this. Of this business plus C1. So this should be the answer, right?
Yes.
Yeah. So I don't think we have violated any mathematical rules or something. So now in the end like this, then you, because there's no other C, then you just you put now the big C, because there's no other C that you can add to this this small c. So that should be your answer, right?
Mhm.
Hmm. Now let's solve the next one. So then the next one is this dy dx is equal to, of course, the separable ones are the easiest. The most difficult is the exact something, is the one that I think is the one that is, we should focus more, because it's the one that is the easiest. These ones, I don't think in an exam somebody can fail them. So this one is also separable, right? So how can you like approach this one? How do you think we can approach this one?
You take y to the left hand side, 6y x.
And then
6y squared.
And then you simultaneously you can also bring dx to
This side, yeah.
So yeah, that's exactly that. That's what we can do. So it will multiply. So cy dy it's e. So it's e to the plus 2. So then you bring dx. So because dx will be multiplying here. I wanted to shift this. Right?
Yes.
Yeah. And then when you reach there, then we have separated it. So you can introduce the integration. Yes. So you introduce integration both sides. Now, how we can integrate this? 6 is a constant. You can take it out. And y squared, it will be y to the third.
Cubed divided by 3.
Yeah, and then 3 to x, it will be
That
to
is
6.
equals to 2y squared.
Yeah, exactly. So it will be 2. So it will be 2y, not squared, but to the third, right?
Yeah, to the third, yeah.
So we are now on this side. In this side, how can we integrate this? What do you think? which integration technique can be applicable here. You see this this x squared on top of e. Yeah, that one is if you differentiate it, it will give you 2x, right? Which is the same like this. So you can use y substitution. I mean, use substitution, yeah? Right? Bro, are we
Yes,
okay?
come again.
I'm saying, you see this, okay. You know, use substitution.
Yeah.
Yeah. So what it means is there's something inside that you set it to u, and if you have u du, so it's easier to integrate. So what I'm saying is, what happens in u substitution is you have another some function which if you set it to u, then you just have to have u inside.
Yeah.
You just have to have u's inside the integration. So
Okay.
for example, this one, if you set, I wanted to do it on a separate, let's shift to this. If we set u equal to x squared, as we are saying, that means du will be what? You differentiate this, it will be 2x dx, right?
Yeah.
And then that means du is equal to this 2x. So now to find dx, you just have to bring this to this, yeah?
du over 2x.
So it will be du over 2x is equal to dx. So now you take this and substitute. Because we have x inside also, so we don't. You just have to divide by 2 only. So that means x dx. You understand? It will be x dx. Yeah. So you just have to have du over 2 is equal to x dx. Right?
Yeah, because we have x there.
So then you can take that one into the integral. So let's proceed. So it will be u, which is, and then if that one is a constant, so it will be 2 outside. So it will be du. Let's not put du first. Let's put, it will be e to the u plus 2 du, right?
Yes.
See, I think we are together, right? I'm not making
Yeah, we are together.
Any mistake. So now,
yeah.
Now you can integrate easily here, because why? Because integration of e to x, integration of ax, like e to the x is just e to the x, right?
Yes.
Yeah. Because if you differentiate e to the x, it will give you e to the x. So it's the same thing. It's like the integration is a reverse of differentiation. So, so e to the x, we said it's e to the x, and this is a constant. That means it will be 2x. So it will be e to the x plus, we are using additional, you call it what? You differentiate e to the x, then you plus integrate to 2. So it will be 2u, right?
Yes.
Yeah. So now after that, we have done, we can just substitute, and substitute you put inside. So it will be x, we said x squared plus 2x. So that is our integration. So don't forget to put the constant C1.
C.
So now you can copy this to y, because we were just dealing with one side only. So this we already did it. So that is you can leave it like this, as like the lecture said that. But if it's multiple choice, then you need to simplify further because why? Because sometimes the answer can be a simplified one. Like, so you can simplify further to have only y. So, right? So
yes.
To quickly simplify it, then you can take this half, distribute it inside. So it will be EX divided by 2 plus this will cancel, and then it will be X, right? And then it will be plus C1. Okay. Because C1 also is supposed to have the 2 because it was inside the integration, right? It was not outside, so it's wrong to put it outside. So that means you consider 2(1) or C to the power divided by 2 like this. Now you can take this 2, this one also. How? Because you just divide both sides. I mean, yes, you divide both sides. So here it will be e to the 4, right? And then here it will be x2 plus here it will be, because your C1 divided by 2 is also just C, right? It's a constant divided by a number, which is a constant, so it's just C, right? So it will be just C1. Or that's why you see the importance of putting C1, because it's not the final C that we want. So that's why they say it's advisable to do this. So now, having done that, then it will be a cube in the end, yeah?
Yes.
To have y. So this should be the answer. Or maybe let me just verify it. So that we should know where we're getting things right or where we're getting things wrong. Let me just check. But so far, I think, is there any problem?
No, there's no problem. Clear.
Clear, okay.
This is still separable, right?
Yeah, these are all separable. The first thing you separate and then you integrate. They are all separable. So we said today we are supposed to do we are supposed to do Bernoulli and this just for today, so that we don't do much. And then next time we'll be continuing.
Before Bernoulli, there is
There's what?
Wait. No, it's fine. It's fine.
Okay, the question that was on the paper, it was x plus 1. You understand? Here inside, where? Let me show you. Here.
Okay. There's no difference.
There's no, yeah. So, but the answer they got was different, but this one also is right.
Okay.
Here there was 1. So if I verified with this application, photo math, you know, you just take a picture and then it will give you the answer, right?
Yeah.
Yeah, so it's giving us the different one because there was one on the original. But so far, the way we have done, that's how it's supposed to be. We haven't, if this was the question, then we have done it.
Yeah.
Now, let's just go to another one. Or maybe we can just do separable today, or if you are tired, of course. Because I think you're the...
No, we continue. Let's just do another example of separable so that it can stick in the mind. Another example.
Yeah, exactly. So the third example is that but the third one, this one is a separable, but at the same time it's initial condition, right? So it will be good also to do it. So it's dy dx is equal to 6y squared. So the initial conditions are y is equal to 25, 1 over 25. I think you can see properly, right?
Yeah, I can see.
So that is the question. So when these are initial conditions, that means when you get your answer, you substitute y to 1 over 25 and then x 0. You see? So that is x. 0 is equal to x and y is equal to 1 over 25.
1 over 25.
So this is easy. Then let's just separate it quickly. The separable ones are the easiest because it's easy. You can see, definitely see that. No, what I'm doing is wrong. This time yeah. So you see, no, what have I done? Maybe I didn't copy it properly. No, I've copied it properly. So it will be, you see, you can take this 2y to this side, right? So it will be dy, and then you divide by y squared is equal to 6, and then you take dx, right?
So you separate them.
Yeah, now it's separated. So now you integrate, then you simplify or to a certain form or shape. So now this y squared, you can rewrite it as y like this, right?
Yes.
And then this is 6 is a constant, then it will just give you 6x plus c1. This we have already done with it, but we are remaining with the left-hand side, right? Now,
yes.
So if you add 1 here, it will be minus 1, which is 1 over y, right?
If you come again,
if you add 1 here, so it will be minus y, which is 1 over y, and it will be negative because you are dividing by minus 1.
Yes.
So it will be negative.
If you just take y negative 3 over, no,
negative 3 is negative 2 here.
When you add negative 1, I plus 1, I mean,
it will be minus 1. The answer will be
y over minus 1 over 1. Yes, then.
Yeah. So this is correct, right?
Right. Minus 1, y negative. Yeah, this is correct.
This is correct. So then we are done. We can just copy this thing. And then if you want to proceed, then I think it will be this over like this. Yeah. If you want to like reciprocal.
Yeah.
So That's what that means. The answer will be this. Right?
Exactly.
So that means we are done with that one. So when you reach here, then, okay. We forgot that it's initial condition. You remember? So how you do that? This is the simplest you can have, the simplest form. This stage. This stage. Because here it's the simplest to find. So you put 25 here, 1 over 25, which will be 25, right? It will go up. And then is equal to 0, 6, 0, 6, which is equal to 0, and then plus C. That means C is equal to 20 minus 25.
Oh, we have to insert the 1 over 25.
Yes, I said these are
so it will be 6, 0. Yeah.
So it will be, I said, so let's write it. Let's not be like lazy or something. We said 1 over minus 25. So it will be 25. It will be 1.
Yes.
25 is equal to 6, 0 plus C1. Right? So that means 0, 6 times 0 times 0 is 0. So it will be minus 25 is equal to C1. All right?
Yes.
Now the equation changes. How? Where there is C now, you can just put minus 25.
Yes.
So it will be Y. We are using this one. Minus, this is 6x minus 25. This is the equation.
Okay.
Yeah. So I think we can, is there a problem with this one also?
Which one?
The one we have just done. Is there problem, any problem?
No, I don't see any problem.
Okay.
I don't see any problem.
Okay, so then let's solve another one. Where is it's also another initial condition, but it's the fourth one, which is dr d theta is equal to r squared over theta. And the initial conditions given were r is equal to 1. I mean, r is equal to 2 and theta is equal to 1, right?
Yes.
Yeah. So it's the same business we're doing. You separate and then you integrate. So how are we going to separate?
Theta over d. No, it has to be first d.
It will be what? It will be dr squared is equal to 1 over theta.
D theta over theta.
And then d theta, right?
Wait, why 1 over theta and not just theta?
Yeah, because it's, this is the same as r squared times 1 over theta. Right? This is multiplication. Right. Yeah. So if you take this and then you have this. Yeah. And then now we have separated them, then introduce the integral. So,
Integration.
So it will be the same. This we already did it, just like we said y 1 over y. Oh no, yes, that's the right.
R 1 over R.
Huh? Yeah, okay, yeah, 1 over R. I was just remembering the one we did for. Yeah, it will be R. Yeah, so it's like this, and then it's the same as the integration of 1 over x, which is what? Ln x, right? The theta is just so it's ln x. So it will be ln x and then plus c1. So now with this
ln theta, huh?
Sorry, yes, you're right. It's theta is like so it's yeah. Now you can introduce the conditions and find what is x. So let me just do it with a calculator so that we don't waste time simplifying doing this, right? So where there's theta, you put 1. So ln x1 is what? This is 0.
What?
ln x1.
Where do you keep the 2?
The 2 is the r.
Is the r? Okay. Okay.
It's like when you have function of f of x. You remember? So if you want to substitute, if you say you want to find f of 1, so that means 1 will be x.
Okay.
So now, so ln x1 is what? It should be, I don't know. ln x1. Yeah, it's 0. So if this is 0, then we'll put -2. Then c1 is what? Is -half, right? Yeah, so c1 is equal to -half. And then you substitute. So I think we can move on to another one, right?
Yeah.
So let me see. Sorry for the noise. Where is this? So with this one, I don't think there's a problem, right?
There's no problem. It's clear now.
Okay.
It's clear.
I can't see where I copied the questions. So what other courses are you also doing? Maybe we are doing together. What other courses are you also doing? Are you doing physics too?
No, I did physics too.
What about differential?
I'm doing this differential.
Fluid mechanics?
I'm doing this differential equations and linear algebra. And then I'm doing fluid mechanics.
Okay.
I already did linear algebra.
So, Zach, do you have the questions? I mean, it's like the paper that I wrote. I don't know because of I don't know why it's missing now.
Everything looks clear, kind of. You know.
Yeah. Separable is clear. Now, there was separable and I've forgotten the topics. So you guys are doing only differential equations or plus linear?
What?
I done linear algebra already.
Are you doing only differential equations or plus linear algebra?
Okay. I mean, I'm also doing fluid mechanics, so I will also be doing fluid mechanics. I think even calculus 1, I'll also be doing it just to help others also, just, also for me to be practicing. So calculus 1, calculus 2, I'll also be doing them. But it's like, I don't know why the paper is missing. The one I was taking the questions.
Questions on which topic?
Now from the same. Now I wanted to start Bernoulli, the one that the lecture solved. If you have the questions ready, let's just. I don't know where the paper is. Okay, defeated. Okay, but I have found another paper where another paper is. But let's. But it's like on that paper I wrote them properly. But still, you can solve this one. It's also on the tutorial. It's now we are on Bernoulli. So the lecture gave us this, but to me, some of the questions that he solved on Bernoulli are not Bernoulli. Like the answer that was there was a wrong one. But if I checked with other, so that's why I wanted to. I was looking for that paper. So you see this, guys.
So first of all, we start like, how do you know is Bernoulli differential equation?
Exactly. So that is a task. So this one, the standard form for Bernoulli equation is y prime plus, even if it's minus, p of x y is equal to q of x y to the power n. So this is the standard form. You see, the standard form for linear equation is the same as Bernoulli, only that it doesn't have power n. There's no power n, like meaning n is 1, right? So like this one. So what it means is you check your equation. If you can identify p of x and q of y, the first thing, and then you also have to then identify your n.
N.
So this one, it should be a Bernoulli equation because you have p of x, which is this, right? And then you have q of x is this. So are we good there?
Yep.
So now let's solve this. So first thing, let's find, because I want to take this so that we should be seeing what we are doing. So we are here. So, so we said on your solution, you identify P of X, which is what? This, yeah? Q of X is this. And your N is 2. Right?
Yes.
Yeah. So you now find the first step. This is this is the first step. The second step, you find the integration factor, right? So your integration factor, this is the formula. It will be E to the power 1 minus N P of X dx. That is the integration factor. So we are together, right?
Yeah.
You don't have to prove this thing or drive it. You just have to know that you have to find the integration factor, and this is the formula. So now let's substitute stuff inside. You have differentiation of integration of 1 minus 2. It will give you minus what? Minus 1. Huh?
Yeah, minus 1.
Yeah. So
minus 1.
We have P of X, which is minus, right? So it will be positive now.
Come again.
We have P of X, which is 1 minus, minus 1 over X.
Yeah.
So with that minus 1, it will give you positive, right? If you multiply it.
Yes.
And then now you have 1 over X dx, right? So where you have your answer, your integration factors, linear X, right? Right. Which is this will cancel this, so it will be X.
Why is it cancelled?
It's
E and L and X.
They give you 1.
Okay. Yeah.
So now we are now on the third step. The lecture gave us to do this, but this is what I found more easier, because we just have, by the end of the day, you have to make life easier. So right? Yeah. So this is the second step. The third step is easy. You just have to find the general equation. So the general equation is given by y. This is already simplified, so no need to have problems. 1 over your integration factor, right? And then you have differentiation of 1 minus n. This is the formula I'm putting before I substitute. Yeah, so 1 minus n. Now here you put Q of X. And then dx. Obviously, that means you have plus C1 in the end. We are together, right?
Yeah.
Yep.
Yeah. So now let's substitute some stuff into this formula. This is the general equation. That means after this, then you are finished.
It will still be 1 over X. The same.
So we said our integration factor is 1 over X. Yeah.
X.
So you have -1 times minus x minus 1 times x is x. It's minus x.
No, but q of x is x, right?
Yeah. So we have -1 from this.
Yeah, it's minus x.
So it's minus x. If you take minus outside, then you have you integrate x, which is x squared divided by 2. So it will be minus half, right? And then you have x squared here. Then plus.
Come again, inside.
We are going to take, let me use another color. We are going to set here 1 minus 2, right?
2, yeah.
Which gives us -1. And we are going to insert here x. So which by the end you have minus x if you multiply this one. Yeah. And this, if the integration of this will give you what? You are going to add 1. It will be like 1 plus 1 divided by 1 plus 1.
2.
Which is equal to x squared divided by 2. So it's half. So minus half, you take it to the front. Right? So you're going to arrive at this.
Yes.
Now, so with that, then you are done. So that's the answer. So by the way, we have x outside this bracket. If the lecturer wants, you can distribute it, you see? Like the answer maybe you may find would be, you can distribute it further, but this is still okay. So you can have -1 over 2x squared. So x squared and x, they will cancel, right? So that you have only x here divided by 2, and then plus c1 divided by x, right? So this is the answer.
Yes.
So maybe he may want to put like this. So I think for that we are done. Is there any question?
So there's no more plus c.
Yeah, in the end, like this, you can just put plus c, the big C, because there's no another C.
Oh.
Yeah,
it's fine.
You can just put the big C. I don't know whether was question. I wanted to. The problem with the application I'm using, it doesn't solve Bernoulli equation. So I wanted to take a photo, and then they are saying they are still engineers are still working on this, but yeah, the others they give the answer, but this one, when Bernoulli I give them, they say we are still trying to fix this. So we're not going to verify, but if we haven't violated any mathematics rules, then we should be fine, right?
Yes.
Yeah. So
which applications do you use?
For this checking thing.
Yeah.
This they call symbol lab, but this one is an application. It's not. Yeah, it's not the web page. It's app. So that app maybe is on that. But I think on the website, if you copy it, it can solve. I think because it's powerful also. But only that using like photo math, like taking a picture and then which is quicker. They're saying they are still working on it. So because on that question, I had another question that was Bernoulli. So did you have the question for the tutorials on Bernoulli? Because we need to solve one more. There's one more, but there's one question that the lecture solved. He used Bernoulli and he got the answer wrong because it's not Bernoulli question. You just have to use separable or something. But he solved it using Bernoulli, and there was no Q of X. So I wanted to solve that one so that you see. But I think if we don't find one more example, then what if we call it a day for today until when should we meet again for exact and other stuff that we have in the midweek?
Wednesday.
No, we have
Wednesday.
First thing we need to learn we need to attend the tutorial. So one of the tutorials on Friday, right?
Yeah.
So it won't be good to do it on Friday because we have to do it after.
Saturdays are okay.
Come again?
I feel Saturdays are okay because by Saturdays, there are different groups. So by Saturday, everybody has done all their tutorials. Then we can all bring reports on Saturday and everybody will solve together.
Yes.
Yeah,
Yeah, Saturday is okay, but next time we just get please more examples on this part. And
Bernoulli?
yeah, at least let's say 2 more, or then we continue.
Because on that paper I had, it had the around.
No, it's okay for today.
Okay, 3
It's okay
questions.
for today.
Okay, so that means I'll look for other examples on Bernoulli, but so I'll just combine with exact method. But exact method is more complicated. It needs one special, you understand, without mixing with others. I think so. And then homogeneous, and then we are done. And then we'll see the higher order, what will be the tutorial. So it would be good if you had given the file itself, the PDF for the tutorial, not like the way I did that, because I was just taking a screenshot. Yeah, so thank you guys for attending, and I really appreciate this. It's good to be practicing and solving so that the more we solve.
Thanks for helping out.
What?
Thanks for helping out. You helped me here. Where I had the problem.
Yeah, thanks.
Just made it clear to me.
Yeah, see.
So thanks.
So should I take attendance or? Okay, so goodbye for now. We'll meet there's a group, WhatsApp group for discussion we created, so you should be added there so that we can be discussing.
I think someone added me on the group.
Thanks.
Yeah, so thank you.
Thanks for your time.
Yeah,
thanks for your time.
Really helped. Thank you. Goodbye.
It's all right. All right.
I'm sorry, what question?
What?
That's one question. The recording for this video, how are you going to post it for everyone to see?
We can just post it on YouTube and I'll send the link also, maybe.
Okay. Okay.
Yeah.
Oh, bye.
Bye.